Okay, there we go. Now you should actually hear me. Okay, like I was saying for the last 20 seconds, this is gonna be a hectic one. You saw me put up my drawing tablet, so let me get it out again, this time with sound. This thing. Um, I was trying to get this connected to my screen so I could use it to draw during streams, and I lost track of time. I didn't even manage to do it, which is even more sad. So I'm still setting up everything. I got my screen open that we'll use in a minute, but I do need to set up. So YouTube is on, that's on. This needs to be something else. I also need to start my music, so let's also do that. Where are you gonna pop up? Oh, right there. No, you're not gonna see that. Oh, what man, being on time is so important. Okay, let's get this on. I do need to find some new music as well because I've been using this one. Where is it? Where is the file? This one. For a long time, and I do know like some of the Nintendo tracks are actually not. There we go. Okay, so I do know like some of the Nintendo tracks are not copyrightable or like free use. Why is it frozen now? Oh boy. Webcam froze. Okay, let's just boop, boop. Oh, that one. Boop, boop. Is it good? No. Ah, every single time something goes wrong. Actually, let's already put this up. I'll fix the webcam in a second. Give me a minute. Okay, let's try and do this again. Come on, webcam. No. Oh shoot. Oh boy. No, no. Wait, activate again. There we go. Okay. Damn. Ugh. This has been the most hectic. I can't even speak anymore. God damn it. Okay, so we got all of that working. You can't see this now, but it's already up as well. I need to open you. You go there. Oh, okay. I think we're almost there. Just bear with me for a second more. I need to do this. Now I'm just filling water at this point. I mean, that's not that important, but yeah. I got my drink now. Cheers. It's just water. Still, I need it because I'm not used to talking this much. Okay, so that's gone, that's done, that's all done. Webcam is not frozen. I'm keeping an eye on you, don't worry about it. Well, the webcam is actually there. I'm keeping an eye on you. Okay, there we go. Stream on. This on. Great. Okay, I think we're all set. We can close this for a second. We got our to-do list here that you'll see in a second as well. I really was hoping we could start off with having a little bit of like a overview with the tablet, but oh well. Them's the breaks, I guess. Okay, so let me do the YouTube things now and actually share the stream. This one in here. There we go. It's still open. There we go. 21st of July, actual Belgium holiday. It's national holiday. So I didn't have to work today, which was great. And I still didn't get in time to actually fix everything up and get everything ready. But sure, we're done. I think we're ready. Whew, I didn't actually change. Okay, it doesn't matter. Stop panicking. Okay, so last week what we did do is we got into things after a little bit of a break. Actually, let's take a breather first. Let's start off like we always start off. How has your day been? Mine has been pretty great. I didn't have to go to work today. We had a Belgium national holiday. Spent the day just catching up, cleaning the house a bit, stuff like that. Boring adult stuff most of the time. And then I think that's about it. Yeah. Oh, I did mess around with like I have a friend send me like one of their game engines that they're making. And it's pretty promising. It is 2D, which is separate from what I'm doing because I'm doing 3D, but it's pretty promising, it's pretty cool, it's pretty clean, it's pretty simple. And I've been trying to make a game in there as well to see how it works and how it goes, and it's going pretty well. But that's not what we're going to be doing today. Today we are going to work on my engine, which is called Homebrew, which is about 3D rendering at the moment, because I still didn't get out of that phase. We still have one triangle, but that's actually, I think it's about time we switch it up. So let's go to this part of the stream. Let's see if we can build still, because I don't know what state we left the project in. Oh, I did build. Oh, I didn't see that. Okay. And then boot up. It still boots up. We still have our glorious triangle we made in stream number 2, and now we're at stream, what is it, 11? I think? Maybe 10? Hey, got it in double digits. Not sure. But what are we doing today? Well, let's put it this way. We are going to not change anything in this again. We have a render frame to create. That's basically what we're gonna focus on today. What is the render frame gonna do? Well, I was gonna draw a beautiful picture with it, which was just gonna be a square. But basically what the render frame is gonna encompass is all of our rendering for a single frame of the game. So if you go to application class at a minute, this is how we render. Bad. The render API.render, you can still keep that one, but all of this needs to basically be in render frame begin frame. Let's make it very obvious, right? And then let's also keep these a little bit. I need more space to code. Okay, so we got this, and then we're gonna. What the hell did I press there? Okay. Is this Fortnite? No, it's not. Okay. And then at the end, before we're gonna do that, we're gonna do end frame. And basically, render frame is gonna set up the render command list, gonna set up the render target. It's gonna make sure we clean everything up at the correct time, submit our render command list, and then the actual drawing, because it's the actual drawing, will still be separate, because that's our render frame doesn't know about that. But that's what we're gonna do. So that's what we're focusing on. So first things first is we need to create those two functions. And if you have been following along with the tutorial, but this code with me, I don't know what to call it. With my coding journey, that's a good way of putting it. We are gonna make a interface first. Like we have a render API, which is all interface. There's no definition here stating which render API we're actually using, which is the way we want it. So we are gonna create another header file, and then we're also gonna create the implementation files at the same time. Engine, render API. In here, we're gonna create our interface. So we're gonna create a new text file, which is called render frame. There we go, and it's gonna be a header file. Boom, done. Yes, I want to change the extension. I know what I'm doing. And then in our DirectX one, we're gonna create two new text files. One is gonna be DirectX 12 render frame H, and then I can't type. Thank God I spotted that. And then I'm gonna copy this as well. That, and change it to .cpp. Boom, done. Basics done. Can it? No, okay. Then in our CMake list, which I should have open, this is where we add files to our project. So we're gonna, in our DirectX 12 part, the same thing. We're gonna add a render frame here. I'll type, great. Which is our CPP and our H, and then in here we're also gonna do render frame. Now if I was good, I would sort these. Don't want to worry about that now. We will come back to the CMake. I have a lot of things to change there anyway. But if we now press, why is my mouse so dirty? What the hell? It's like pieces of wood on there. It's not the ceiling. Okay, if we build now, we should see those files in here. So, yeah, so we got our undeclared identifiers, which was expected because we have not implemented it, but we got a render frame. Okay, so prog mods. It's what? Inside here, we're gonna create namespace HP render. Pass render frame. And it's gonna have public, of course. Oh, also it's not gonna be final, but we're gonna have, how did I do it for all the rest? Did I just, yeah, just gonna do this. Ah, render target is just a concept, I guess. It doesn't have any functions at the moment. Like so, render target, change that to frame. I think this is how I laid it out for render target. Yes, same thing. So we got all of this, and then we're also gonna add 2 abstract functions. First one, oh yeah, and we need to include this. So I'll enter include define, so we get this. Then we're also gonna, I like doing another public. I don't know if I've actually been doing that very much. No, I'll leave it then. Okay. First one, it's gonna be a void function, call it begin frame. Equals 0, because they need to implement it themselves. Okay. What are you complaining about? Remember? Oh yeah, virtual void. It's been a while. Okay, so I got begin frame and frame. That's it. That's all we need. So now what we could do is we go to application, set our header. We're not gonna make a render command list anymore. We're gonna make a render frame. Render frame. Not included yet, so let's do this. And then render frame, because we don't need to render command list anymore. Boom, done. Application render frame.get frame. But we need to include it still, so let's do render frame. Oh. That should be that. Render command list. Let's actually save that for now. I'm gonna save all of this code as well. Oops. Oops. Why does this not work? Oh well. Separate this. I am gonna save all of this, because we will use it again in the render frame, probably. I say probably. Okay. Done. This is all done. Great. We'll move this in a second. So now, let's create a render frame. How we're gonna create a render frame? Same as we do render command list, we're gonna create from a render API. So a render API needs to have a function create render frame. So copy, whoops, duplicate this, whoops. I'm still not used to switching the render frame. I want everything to be created through our API. That makes sense to me. This, again, they should probably be sorted, but who cares at the moment. Equals 0. So now in our .x12, our render API will complain that we don't have the render frame function. So we're gonna duplicate it, create render frame. It needs to be a render frame. Go. Ooh, that's not great. Anyway. Almost set up. Let's go. Okay, so then we need to implement this function, because of course we need to. So let's look at our other register or create functions. Where's my create functions? Initialize is still big. Ugh. Okay, they're gonna be at the bottom. Create random command list, create random targets. Let's make another one. Oh, come on, man. Render without dynamic. Great render frame. There we go. Thank you very much. Took way too long. Okay. Whew. And the only thing we need to do is create a render frame, which is very simple. And then return it. So we should just be able to do this. Create unique pointer of a DirectX 12 render frame, which we still need to include, don't worry, I know. Oof, and that's it. We do here, so we need to include this one in the right place, render frame. And it will still be red because we don't actually have include anything here. So pragmods, as always. And then we're gonna be in an HP in a namespace. Render. I'm gonna do class ix12 render frame, which publicly extends DirectX 12 not DirectX 12 render frame. And we need to include that, so include render frame. There we go. And this is final. Let's also put that in there. And that's a complaint because I have not actually implemented anything. So let's go to render frame and we need to include all of this again. We'll copy all of this again. Yeah. Delete copy, delete move. Okay. For virtual, but there are void overrides. They can't be like that. Override. There we go. Come on. And virtual is not needed, as I thought. There we go. Whew, we're getting there. This looks correct to me. So now if you go to our render API that we moved a moment ago, you see that the red at the bottom here is gone because this is now valid code. Valid code means good. Okay. So now we need to actually implement them. So we're gonna include in here is the header file. Oh, come on, I pressed the wrong button. Go, and then it's gonna be void. Let it say begin frame. Also void end frame. And I'm also pretty sure our virtual or the structure is not gonna be default, so let's also add a default constructor here. There we go. Boom, done. Okay, this will give us everything that we need to fill in a second. But let's first press this, see if it builds. It should. I forgot something. Access member. There then class. There's no member. What did I do wrong here? X12 render frame. Oh, I forgot public. There we go. All fixed. Still an error. Following is treated an error. While compiling shader. Pointer to an incomplete type. Oh. That's interesting. Oh, an application. Whoops. I deleted too much here. Shader. Build. That's interesting. I don't think we call shader here, but we do create shader. Oh no, we save it in the unique pointer. Yeah, no, makes sense. We do need it. Okay, so we got all of this. Actual drawing we can actually then leave, but we need to do this. We need to make a render command list. We need to do render targets as well, and we need to swap render targets. I'm pretty sure set render targets and render command lists just gets the latest one. Yeah, it gets current. That's not how we're gonna do it. We're gonna store them. So first thing we need to know is in our render frame, how many frames does it take? Because right now that is stored in, if I call it correctly, frame count here. We have a frame count here. Actually not what we need. I'm not sure, actually we need to check if this frame count is used here. I think it is. Command Q, which is fine. Buffer count, so we create a swap chain here. For what do we create the swap chain? Description. Store it in swap chain. Also, I could fix that because I know how to do it better as well. Do I use swap chain anywhere else here? Oh, yes. Okay. So we do need to store it here. Okay. Alright, let's first fix this. Because we create a pointer here and then do a static cost. There is actually something in here, new swap chain, dot query interface, which will automatically cast it. Oh, come on. What was it? I don't remember what it was. IID. Yeah, this. And we can do this, if I recall correctly. And that's the correct way of doing it. So what this will do is it will create one in here, and a query interface will cast it to the new version, which is the correct way of doing it. Small little upgrade. What was I saying before? Oh yeah, so we need a frame count, which is the buffer count basically. Now, right now this is somewhere, but I don't know where. Where is this defined? Oh, it's just a static in the render API. Okay, that's fine. Buffering count. Do frame buffering count. That will make more sense. We got that. That's static const expert. It's 2. We can have 3, but 2 is more than enough for what we want to do. Render targets should be an array. Should be a vector. Oh, maybe today we'll make a vector. That will be fun. Make array. We could do that. We make our render target heap. That's also an option. I'll put that on the list. Because basically what we want to do is we want to create like a big massive render target heap, because I don't think we actually use this itself inside our render API. So let's actually find references for this. Yeah, so we create it, and then we get handles from our heap, but that's it. We don't actually pass this anywhere. Yeah, I thought so. So we can make this its own make a render target manager, which will do all of the management ourselves, so we can set a limit on how many render targets we want. That will be nice. So we'll put that there, and we're gonna put it on the scratchpad list also before fence class, because I don't feel like doing that today. Manager, that makes more sense. But back to our render frame. Okay, what is our render frame gonna need? So, like I said, it's gonna take in an int buffer count, render target count, buffer count. Right? Great. Oh. Yeah, and then we're gonna have to make a private members. So we're gonna members. First of all, we're gonna save that members. So we're gonna create an int in buffering count. Huh? And that's the first thing we're gonna fill in. Buffering count. It's not a null pointer. It's whatever we give in here as buffering count. And typing today is not going well, isn't it? Buffering counts. Right buffer? Oh, Jesus. So, there we go. Oof, that took way too long. Nice. Got our render frame almost set up, I think. So we got our buffering count, and this is all we technically need. What we're gonna do now is, I'm pretty sure if we create a swap chain, I'm not sure anymore actually. Frame count, this should be is buffering frame count. Frame buffering count, apparently. Well, actually let's fix this first, because apparently it's used here as well. And here. And here. Yeah, so see, we want to, this we'll put in the render target manager. Anyway, so what I was checking is we create a swap chain, right? You don't pass any render targets in here, which is what I wanted to see. Just click a swap chain description and a new swap chain. And then do we ever link them together? Because we create a render target heap here, descriptors. And we create two render targets. Create a root signature, which is empty. Loading assets, skip over this, skip over that, fence. Oh, this is the wait for function. That's creating the fence. Then we render. We execute command lists, and then we present. Hit wait for frame, throw loads. Ever. Link or swap chain. Oh, there we go. Yeah, so see, this should be done in our render frame. Because we're not going to create all the render targets here. Just get resource buffers. And this is where we're going to create our render target in. Okay. So this is going to be a little bit complicated now, because for the swap chain, when we create it, we want those two to be filled in. So we need the resources already. man, I knew there was gonna be some kind of issue in here. Good that I had a little bit of time to fix that. Okay. So normally to create a render target, do you always need to create a render target, do we always need a resource? Because then it's not an issue. X12. You always need at least one P for the P description needs to be. No resource is used to initialize a null descriptor which guarantees. Represents the render target. So there's only one way to create a render target, so that resource. Oh, that was bright. Ooh. So this is gonna be awkward because we need to supply the resource, but the render frame doesn't know about those resources. The render frame needs to request those resources. We can do a request buffers, I guess. Yeah, that's an option. And we'll get swap chain get buffer, or get swap chain buffer, and then make the resource there. But we can't always get the resource here. The create of the render target should already take a resource. So let's fix that first. The create of the render target. Oh no, can we do that? Uh-oh. Whoops. Can we do that? No, I don't think we can. You know why? Because, you guessed it, this is... Oh. So if you create a render target, we should waste that, but then we need some play. That's a null pointer. I don't think it should be supplied in a pointer. Managed. Yeah. Managed by tab. No, it's fine. Double delete is fine. Okay. X12 create resource, create render target. Let's look it up. Okay, this example, please. Thank you very much. How to texture this? That's too much code. I just want to create a render target. See, we need to zeros, rights are discarded. I don't. Oh, let's go back to the code. So create render target view, and then we can either give it the descriptor or this. Ah. So if we create a descriptor for it, what happens? Mention. Oh, and a bunch of arrays, so you just need to buffer basically, so that's all fine. So passing it like this, so we always will need a buffer. That's strange, because then we need to figure out how to do that. I mean, we have a create render target function, but we need to create a resource buffer. Right, so how do we do that? How? Because DirectX assumes we already have one. Oh no, we get it from the swap chain. We are making a problem out of nothing at the minute, because every single render target we have comes from the swap chain. But later on, that is not gonna be the case. Right, so what if? Hold on. Let's just ignore the problem for now, maybe? Okay, we'll ignore it for now. Which is strange, but we'll ignore the problem for now. And then what we're gonna do is... What was I doing before? Oh yeah, we were creating the render targets for the swap chain. Because they need to be passed to the render target. Okay, so... Let's start with the render frame. We're gonna need... So we got this int. We're also gonna say... We're gonna have an... Oh, this is gonna be great. HB render target array, but it's gonna be a dynamic array. So HB unique pointer. So we have a unique pointer of render targets. Also, we need to include that. So namespace HB render, and then we're gonna do class render target. Actually, we can do class DirectX 12. And that's what we're gonna store in our unique pointer, but it's not gonna be one unique pointer, it's gonna be a list of unique pointers. And then render target. Right. Little bit of a problem here. This is gonna be an array, so we also will need a destructor, because we don't have to do place with dynamic array, with static array. No, it's not a static array, it's a dynamic array. Either way, we're gonna inside here also create our render targets, which is gonna be a new HB unique pointer render targets array. It's this one. Buffer count. Great. And then in here we're gonna do delete array of render targets, just to be safe. And then in here we're gonna actually initialize them. So 4, that was correct. Where did it go? Int I 0. There we go. Buffer count. And then we're gonna say render targets I equals, and then we're gonna have create a render targets here. So we need the render API. That's the only time we need the render API, probably. At this point, I should make the render API a service, so we don't have to pass it along every single time. Or a singleton, but I don't. I mean, it makes sense that it's not a singleton, I guess. Yeah, I mean, it's fine this way. This way, the destruction is guaranteed to be correct, so I'll just pass it along. So in the beginning here, we're gonna say DirectX 12 API, get the int. This should probably be by const reference. Actually, I think we're gonna need it as well in the render frame. So actually, that's how do we pass it normally? Pointer, I think. Another command list will have it. Yeah, just pointer. So let's put that in there as well. Hello, welcome to the stream. Hi, there we go. And here, so let's just pass the pointer. Render API. Put in there. Nothing. Oh, move. Right. Oh, it's a unique pointer of. Okay. Never mind then. Just normal render targets. Oopsie daisies. Oh, we don't need to move it. That will go to. Yeah. That's what I thought it was gonna do. Target, yeah, okay, and now I just need to do this. Yeah, go to this one, paste it in here, there we go, and then on a render API, when we make a render frame, we're also gonna have to pass this, and in frame count. But audio is too low. Hold on, let me just frame buffering index. There we go. What is that? Okay, anyway. Oh, let's see the settings. I mean, it's okay on my end. Oh, this is a bit loud. That's better, I guess. Sure. I mean, settings are normal, I didn't change anything. Seems okay on my end though. Music seems a bit loud. Wait, hold on. This. That to -5. Not 5, -5. Save. And then it should be all fine. I don't know. I mean, it's plugged in. It's showing me it's going. Yeah, active. There we go. What? Just, huh? I mean, any louder, and I'm going over. I'm going over my limits here. I mean, I'm boosted a little bit, I think. Hold on, let me. Let's see. 12 dB is too much. I'm going overboard then. Okay, let's see here. Right one. It's using the wrong microphone. This is gonna be way better now. Oh boy. Okay, well. Thank God for OBS chose the wrong microphone. Oh boy. Well, anyway. There we go. I'll put this back to 5 dB. I mean, it's been a stream of technical issues a little bit as well. It's not M-frame buffering, it's S-frame buffering. Okay. Well, anyway, now you should be able to like hear me very clearly. The difference a microphone could make is insane. I was using my microphone for my headphones, but yeah, of course not. I wasn't extended or anything. But I have like a dedicated microphone on my desk. Ah, boy. I can hear you now. Thank you for noticing. God damn, it's been 45 minutes into the stream. Jesus. Oh, great. It's gonna be great to watch back and hear myself not talk. Okay. So, hello, welcome to the stream. Came at the right moment. My microphone is fixed. Okay, so let's concise what we've done this stream, because apparently you couldn't hear me. So, last time I fixed a major bug in my system where I was using the wrong library. Really bad on my part. Anyway, fixed that. Today, been working on making a render frame. This render frame is going to encompass all the rendering we have for a single frame in the game. So if we go to our application class really quick, all this commented out code is gonna be inside that render class and the render frame class, and it's gonna do a lot more as well. But what it's basically gonna do, except this actual drawing, it's gonna make sure that the render command list, the thing we actually record commands in, record the drawing in, is gonna be set up properly. It's gonna be sure that the render target's set properly, so we are drawing to the correct screen or the correct buffer or whatever you want to call it, and it's gonna make sure that all the management of that render target and the render command list is done. On top of that, it's also gonna make sure that when we end the frame, it's gonna swap the buffers, so our swap chain works perfectly fine. And that's about it. And that's all the render frame is gonna do. So it's gonna set everything up so you can start drawing to the screen, and then it's gonna make sure that everything is correctly ended at the end of the frame so you can show it to the player. And it's gonna set up the next frame as well that we use the correct resources. So it's gonna do resource management and then just frame management. And where were we? Where's my music? Now my music is gone. Oh no, it's just very, very quiet in my ears now. Hold on. I think this is better. Okay. Jesus. Oh boy, you think you have things set up after like 10 times, but no. No, okay. Where was I? So we create the render frames here, we create the render targets here, so these are the ones we are gonna use. And then what I normally did in a render command list is I get current render target. I don't know what this function does anymore. Oh, it's just a frame index. And what does frame index do? That's okay, let's use this. Where is frame index is here. It's probably gonna update get current back buffer index. Yeah. I'm building on top of DirectX 12. Which should be pretty obvious because I have a swap chain, although it could be broken, but I have the DirectX 12. I have DirectX prefixes for everything that is DirectX 12. Although I am making sure I have interfaces for everything, all these things, putting all the DirectX 12 specific code in a single folder and single files, so that when I want to swap to whatever OpenGL, Vulkan, whatever metal I think, whatever Mac uses, that we can swap that out. So that will only be that one single folder, all of those interfaces that have to be implemented,
and the game should run exactly the same. Same with Windows, by the way. I'm also putting all my Windows Win32 stuff in separate files, so that when the time comes to go to another operating system, it's all separated and it's very easy to replace. It's thinking ahead. Okay, so swap chain. I don't think I need to do this technically. Right, where do I use this frame index? Is it just that one? Oh no, we use it here as well. Oh no, it's just the get current back buffer index. Ah, okay, and then we use it here as well. Just to make sure, I guess. Do I pause the swap chain? That's actually a good idea, maybe, if we put the swap chain in the render frame. This is gonna be a difficult one. I don't think so. I think we just keep it like this. We don't worry about this anymore, but we just manually swap it ourselves. And since we should have done everything correctly, assuming everything went correctly, although we could, yeah, we're gonna set it up correctly. So the frame index is gonna disappear from this. Actually, let's just do it in the render API itself. And header, I mean, just gonna remove the frame index. Scary now. And if we do management correctly anyway, we don't need to worry about this. Because get current render target's also gonna disappear, I think. Yes. DirectX 12 render target should know its handle. Yeah. Interesting. Why do I do it separately? Either way, gone function, gone. And then also we can remove that function from this one. Boop. And then it's gonna complain about something somewhere. I think in the render command list probably. Yes. Set render target. It's not just gonna be like this anymore. It's actually gonna take a render target now. Oh, come on. Add for declare, it's gonna take a pointer. No, a reference. A const reference. A const reference? Can we do a const reference? I don't know. No, just a reference. Let's make it a reference. This is pointer. No, it's gonna be a reference. Like so. And then we're gonna cast it to a DirectX 12 one. And then we're gonna get the resource. And then we're gonna get the handle. Oh boy, what's the CPU handle? Whoops, where is F12? There it is. DirectX 12 render target dot get CPU handle. And then there we go. So that fixed. Release render target. So again, we are gonna have to gather this one. Remove all of this code. I don't know if we actually need, yes, we do need it to be DirectX 12 on. We need to call get resource on it. That's it. And then both of these will have to get this. Oops. There we go. And then as well, the basic version will also need this, and that means we're gonna have to implement, well, include the render target class. There we go. Okay, boom, boom, done, done, done. Great. Okay, render frame time. So we got our render targets here. We are also going to set our frame index, I think. So this is gonna be const, which is gonna complain about that it's const probably. Why are you complaining? Oh, it's not used. Render API is not used. We'll use it in a second, don't worry. Override is not, that doesn't need to be marked as this. Padding to alignment boundary, that's all fine. Replace a dynamic array. Okay, got all of that figured out. So then we're also gonna add a normal int, which is render target index. That was actually correct. And this is gonna say which render target is active. At the moment, I don't know, right? We assume it's the first one. So let's put that here as well. Let's put render target index at 0. And at end frame, why did I put that at begin frame? Oops. Should have been yelling at me for that one. HB render, there we go. And then delete should be in here. End frame should be render target index plus plus, but actually it's faster to do this. Okay, so now let's look at what we actually need to implement here. We need to do render command list. So we need to get our render command list. Interesting. How do we get our render command list? I don't remember. We just create one. Okay. Okay. How to create one? Oh, just because we submitted, I guess it's fine? Yes. So for a render frame, you can just create one. Technically, we should create one per render target, probably, but we're gonna reuse one, so that's all fine. So from our render API, from our application, we can actually remove. Oh, I already removed it. Great. So we're gonna create a render command list here. Render command list. Here we go. Unique pointer of render command list. There we go. Boop, boop, boop. Render command list. Oof. Oops. Not you. You. There we go. Nice. Okay. So again, not used. We will use it in a second though. And then render command list. You can probably just render command list. Oh, render API, we also need to fill that in. Yeah, that's correct. And then render command list, which I think is actually above. No, render API is the top one. Yeah, I know it's a bit messed up at the moment. Shut up. Render targets, render command list, which is gonna be create. Oh, it's just gonna be render API, create render command list. Nice. Very simple. It's not gonna be plus plus, it's gonna be equals whatever it is right now, plus 1 modulo, well, it's gonna be a long time since I've used the modulo counter. So what this is gonna do, it's gonna increase the buffering count by 1. and then take the modulo, which is dividing it by the number and taking the remainder. So since this is gonna be 2, if our render target index is 0, it's gonna do +1 remainder of that divided by 2, which is still 1. If we get 2, however, the remainder is 0, so we're gonna switch, technically toggle between 1 and 0 here. But if you have more buffering count, we should count up, so it's gonna be, if you have 2, it's gonna be 0 and 1. If you have 3, it's gonna be 0, 1, 2, and then back to 0. So it's just gonna loop around every single time, which is nice, because then we can get the correct render target in our begin frame. And I think at this point we can actually, yeah, let's yoink this over for a second, copy this, and paste it inside our render frame. Paste it here. Does uncommon work? Yes, it does. The drawing code we can actually remove. So the render target, that's begin frame. Release is going to be end frame. So let's put that in here. And then we need the render target, and the render target is going to be the current one, which is going to be im render targets with the rendering index. Look at. And then, actually, can we just do this? Oh, does our unique pointer not have that? Huh, interesting. Do we just pass pointers? Maybe. No, it should exist, so let's do it this way. And then make sure that our unique pointer has an overload for that. So if we star it, we should get a T reference for operator star. That was correct. And then we need to implement that. So where's the operator? Here it is. The reference operator return m pointer. And then we also need this. Of course we need this. Boop, boop, boop. Done. There we go. This might be unsafe at some point. Who cares? It's my engine. I will make sure it's not safe, not unsafe. And then we release it, we finish it, we submit it, and we increase this so we can get our next one. Done. Frame management done, I think. What are we forgetting? Ah. Okay. Nice. So I think we're almost at the point where we can run this again. The only thing I need from the render frame is maybe a get thingy as a get command list. Yeah, probably. So we're gonna have this. Reference get command list, not override. Whoops, I did something else. The render frame will always have a render command list, so we can actually do this as override. Nice. Command list, and it's gonna return a command list. So then we also will need to include that here. Namespace. Hue. That's an unnamed namespace. I need this one. There we go. By reference, thank you very much. And then you get render command list override. Yeah. Do I call it get command list? No, let's call it get render command list. Let's be consistent. And then in here, it's gonna be a simple function, but let's just do void get render command list. And it's gonna be return render command list. Done. Bosh. Great. Okay. And then in application, I think we can just remove all of this and all of that and then all of this. And then you can just say HP render command list reference render command list is render frame, and then actual drawing. Let's uncomment this. Ah, what the hell is happening here? Okay, copy that, and then put a dot in between those. Incomplete type, of course. So let's also add render command list. Whew, okay, and then compile and hope I did everything right. No, apparently not. Great. Start at the beginning. Element to conversion from ternary conversion. This one. Oh, is that a UN32? Whoops, oops. So whatever this type is what we're gonna give the type here. Buffering index, and this one as well, which is scary, but fine. And then you as well should be this. Put a space here. That should be all fine, should be all fine. That's fine. Build. And this is gonna complain because this should be size T, I guess. Might not complain about this. Oh, great. Let's see if we did it correctly. Oh no. Uh-oh. Okay. We did not make a render frame yet. Okay. Whoops. So let's, instead of this one, let's do render frame. Render API dot create render frame, please. Do I need to pause anything to this? I actually don't remember. No. So should compile. Okay, compiled. No, debug break. Okay. Too many render targets. Huh? Oh, because frame buffering count is 2. And guess what? I already made 4 now, because create command queue, create swap chain, create descriptor heap. Don't need to do this. We don't need to make, wait, what? Where's these? render targets? We don't have that anymore. So let's do that. And then inside the render API, render targets. We don't have that. So let's see if that breaks anything. Doesn't seem so. Let's build again. Stop and build. Okay, then blew up. Oh, hey, look, triangle. Oh, this is great. This is good news. Man, I was hoping this would happen. I was afraid I was gonna have to debug something here. Let's check if we have any. No, I don't see any memory leaks. No. Okay, that's fine. Perfect. We added last time is a memory debugger for DirectX 12. So if there's any leaks, they should pop in here, but I don't see any. So that's, well, no, wait. Okay, that's dynamite. That's all fine. That's all good. So now our application looks very simple, right? We set up a triangle. Don't worry about this. We'll fix that later on. We fill our render queue. We get our render command list for this one. We start rendering. And then end the frame and then render. That's great. That's perfect. Okay, so let's go all the way back to the beginning here. This is done. Begin end frame. Need a command list, maybe get an active render frame. No, that's all fine. Done. Okay, so the only thing I want to take a look at still is, well, we can do that, but we can also take a look at the issue we had before, right? Because we technically just skipped something. If we make a render target, which there is a function for somewhere at the bottom here, create render target, we always assume it's from the swap chain. Bad. I think that's bad. I'm not actually sure. Right. I mean, what we want to do for this render target is we're gonna make a render target descriptor heap. A big one. With all the handles for render targets. I don't know if it's bad to make multiple or not. I'm just gonna make one. I'm not sure if we need to push that or anything. I don't think so. Descriptor size. Yeah, we also, all of this is gonna be to, like, do we use this anywhere else? No, it's just to create them, right? Yeah. So normally we have a resource, and that resource will determine where we put it. And that resource can be in the swap chain or can be in some kind of resource buffer description, which I think also exists. So basically we need to get rid of this. This line should not be in there. But we can also not actually create this. Well, we could just make a resource. We can actually do that. Yeah, we can just say resource and then create will always take the resource. I think that works. And then we wrap DirectX 12 resource as well. Which is a bit stupid, but yeah, it works. That is an option. And then we can get rid of it because we can pass this in here, the unique pointer or the address, probably just a normal pointer, I guess. Okay. And then fill it in. And we give it a get raw function or whatever, which is gonna give the pointer. Oh, this is DirectX 12 pointer. Yeah, no, we're just gonna, yeah. That is an option, I think. And now we can create a resource. From an existing one. Yeah, that's also an option. That is a plan. That is a plan. But before we do that, let's just make the descriptor heap. Actually, let's look up if the multiple descriptor heaps is a good or a bad thing. So, create a descriptor heap. Creating different render target view descriptor heaps DirectX 12. DirectX 12. Is it bad? Optimal approach. But there's no real one optimal. Main limitation to have only one active at the same time. you implicitly have at most one for render targets. Via render targets. Okay. So since we can only have one active at all times, I don't see a point in making multiple at the moment. So we're going to just make one descriptor heap for render targets. I think that's a good idea. This will be DirectX 12 specific, so there's no need to make it an interface. Yeah. So we are going to set up our descriptor heap. Again, make some new files. DirectX 12. We're going to create 2 new files. DirectX 12 render target heap manager. That's a very long name. Ah, I pressed escape. Shoot. DirectX 12 render target heap manager. Actually, let's just call it render target heap. That's all it needs to be. It's not a manager. It's just managing the heap, but that's perfectly fine. It's just a wrapper around the heap. And a CPP file as well. Oh, yes, but there's a space in there that I need to get rid of. There we go. Let's copy this, and then I do know this file. Yes. Close this. H. There we go. Got the render target heap, so if we rebuild it, it should be in there. Get the render target heap now. Okay, so pragmonts. Namespace. HB. Render. Now we're gonna make a class. Render target. DirectX 12. I still need to target heap. Oh, shoot, come on. And I also noticed that it's spelled wrong, so it has a small x, which is annoying me. There we go, those two fixed. Not the CMake. Does the CMake show in here? It should. The small things. Okay, so it's DirectX 12 render target heap. There we go. And it's gonna be final. And then first things first is constructor. It's gonna take in a max heap size, which is gonna be uint32t max heap size. Max render target count. And it's also probably gonna take in the render API. What? I need to include something, but I don't know which one does it. For the uint32t. Oh, it's not in here anymore, it's in render frame. Oh, it's unique pointer already includes it. Oh, probably because of type traits. Ugh. Okay. We are going to include... Oh yeah, it's fine, this one. It's fine. Did I close it? I did. Okay. Got that. Then the destructor as well. which is gonna be default. No need to make it. Oh, then it's gonna say virtual because it's final. So then we do a delete, copy, copy and delete move. Same thing. Oh shoot. And it should all be public, by the way. Oh boy. And this is where we actually should have a dynamic array or a vector or whatever you want to call it. But we don't have that yet. So first things first. Actually, I'm gonna put that on the list. Create vector, because it's not the first time. And I like the name dynamic array more, because that's exactly what it is, rather than a vector. Vector doesn't, I mean, it's unanimous with what it is, but I like dynamic array a bit more. Okay, so, shoot, come on. Keep that one, that's a good one, although we're gonna call it capital max render target count. There we go. First one off the bat, done. So what are we going to do? Well, we need a create render target function, which render API already has. So first we need to make the descriptor heap as well. So this should happen when we create it. So we need to copy all of this, put it in here, in here. We're going to include render target API. Then we're going to do directs12. Render target heap, render target heap, and then we're gonna do bam. Also m.max render target count is max render target. I pressed the right button this time. Okay, why? No, render API, that's what I need. Yes. So we are gonna include it's already in here. This one. Why is render API in here? Should not be there yet. Number of descriptors is this one. Throw if failed we don't have. M device we also don't have. So we're gonna make a heap now, which you can clone get from here, which is this. Actually, let's yoink this. Put it in here. Directs12 unique pointer. Let's include that. And apparently that already included all the rest, so that's fine by me. But yeah, let's just include whatever we did here. Let's just include that. Because render API already does it, right? Yeah, let's just also do this one. And let's clean up this a bit. Nice. Okay, great. Done. Bosh. Great. We got all of that set up. Render target heap we have, and then device we don't have, and render view descriptor size we also don't have. Is that another one? Oops. This one can also go left here. See, this class is getting smaller, which is great. I like that. And let's put all of these in a correct order. So that makes sense. Render target count at 0. No, we don't want to initialize that here, but we want to initialize it here. So heap start, we fill that in somewhere else. this and this we fill in separately, so we just need to do render target count. Like so. Throw if failed. I mean, we could implement that. Having to use the device, we could. Does render API already have like a get device? No. How do I do it now actually? Ooh. Do I do this thing? No, it's specific, so it doesn't really matter. I think this is all fine. The only thing here that makes no sense is that we need the device, and the device we get from the render API. So the render the target heap, we will need to pass the render API in, or the device. And I think just passing in the device makes more sense. So let me see if I can find what the device is again. This one. So copy this. Render target heap. Paste. Device. Boop. There we go. And put a pointer of it. Copy that here, here. Device, device. Yeah, throw if failed. We'll fix that later. We can actually fix that very easily. The throw if failed, because the throw if failed will just give us an age result. Res equals this, and then we're just gonna say HP assert, which will include succeeded res, and then could not create RTV heap. Exclamation point. There we go. Let's put these two together like that so that we know for sure. There we go. Bosh, done. We can have this. So render API. We removed all of those things. We will have a lot of red here, but instead we will now create a unique pointer. Not a unique pointer. Let's call it. No, unique pointer makes sense. Do we need to make a unique pointer? No. We can make an actual object for it. HP render. So this is always better if you don't have to make it on the heap. What was it called again? Render target heap directx 12, this one. And we will need to include that. So heap directx render target heap. Just to make it a little bit more neat. Wait. Ooh, pressing the wrong buttons again. Render target heap. There we go. Actually, that's fine to keep it together with that one. And then render target heap equals render target heap and we need to oh wait, no, it doesn't have a default constructor. Oh, it needs to be a pointer. Whoops. Oh boy. Okay, unique pointer it is. It doesn't need to be, but it does need to be. And then, yeah, That's just a normal unique pointer. So it's not an HP render. There we go. Do I have a unique pointer in here? Yes, and there is 12 unique pointer. And this one can go again. We'll save it because we'll need it in a second. Good heap. Let's go. There we go. In here we are now going to include the one I did a second ago. And then back here. Create unique. HB render DirectX 12 render target heap. Hello! Oh, it's the Mac. Welcome back to the stream. Yeah, I'm making a game engine, as you know. Oh boy. Okay, render target heap. What do I need? I forgot already. Device and account. Okay, so the device we should already have, which is just mdevice. But we need to get raw. And then count, which is the frame buffer count. There we go. And then this whole thing can just go. Great. Done. And then in here, this will also all move, I think. Because we do need the device. This buffer thing, we're gonna figure out in a second. But yeah, I think that's fine. We need to do a create render target on a render target heap. So first thing we're gonna do here is do an HB render DirectX 12 because we know it's DirectX 12 render target. And actually, do we do that? Do we pass that by reference or do we create a unique pointer immediately? We can do the if it's a unique pointer, then we should probably do this. So that, copy this, specify a unique pointer. I love how programming always is like breaking everything and until it's fixed. So class, and then it's gonna be render targets. So it's always gonna show a lot of red. Okay, and then we're gonna do create render target. Boop, like that. Actually, you're probably gonna have to put the resource in here. So can we already do that? Yeah, let's do ID12. What is it? D3, D12. Resource pointer. Resource. There we go. And then in here, we're gonna have to create that function now. Oh, I still need to find the best way to do this. Unique pointer of a render target. No, render target. A normal render target. Oh boy. Every single time it's so complicated. Create. No. Oh boy. Get me help. There we go. Now you're helping. And you know I'm gonna need the resource. Just put it in there already. Whoops. Pressing the wrong buttons again. Okay, and then copy the unique pointer because I made a mistake and this should be a unique pointer already. And apparently that's not included yet. Include unique pointer. Just put it. It's nice to have like all of this autocomplete and stuff, but I mean, it needs to work as well. Okay, so we got this, we got the resource. Now we can just yoink all of this. Yoink. Copy it for now. Yoink. Get back to the render target heap. Paste it in here. Frame buffering count. It's not what we have. We have a max rendering target count. Come on, max rendering target count. Yep. Okay, so we still got the old one. Throw it failed. We don't have a swap chain yet, which is interesting. We don't have this either, so include that one. Oh, create unique pointer of that, and then can we just do this? If we can, that's amazing. We'll see. If this gives issues, we're gonna we're gonna change it. Okay, device, we didn't store it. Great, good on my part. This we actually don't need because we have a resource, so we can remove that. We don't need to do the resource get raw because we have it. Device we can actually save, so we can keep track of this reference, but we're not owning it, which is why it's a pointer. So in here, let's do that, and then let's do a, I don't remember what it is. Oh, it's right there. Copy this, poop, device. That's not what I wanted. There we go. And then copy this, put it in here. Let's put, it's not accounts first. No, device is going to be the first one. So let's put a semicolon or a column or whatever. Boop, done. And then device. Now we have a reference to device. Let's actually use that in here where we can. And let's use this as well instead of that one. Yeah, okay, and render target count is just 0. Let's just put it explicitly at 0 because I don't trust myself and I don't trust the compiler either. And then this function is done. Great, okay. So then in render API, when we create it, we don't need to do any of this. You need to get the resource and then we just return or heap. Oh. Ooh. Yeah, this is gonna be an issue. Okay, but I do know how to solve it. Okay, so let's fix this first. Device, render target heap, and then, oops, create render target resource. Listen to me, there we go. Don't get raw, is it? Okay. And do we actually need the unique pointer? No, I don't think so, right? Because we just store a render target heap and then we resource, create a unique pointer, and render targets. We'll just make it have a point. Why do I make the unique pointer? The swap. Okay, this is interesting. I don't know if the swap chain actually ref counts them, but it will automatically make a unique pointer for me, I think. No, unique pointer should be explicit. Did I make unique pointer explicit? That's actually a good question. Let's check that first. Because unique pointer should definitely be explicit. It is not. Good that I checked. Explicit. Jesus. Oh boy. This one as well. No, this one is fine. I need to explicitly define it. Okay. So where was I going wrong now? I still have other things to fix. So render frame, that's all fine. What was it? Render target. This one. Create unique pointer of a render target with just a resource pointer instead of a... I don't know if swap chain actually has ownership of the resource, so of the buffers basically. Probably it does. And render target is just owning it, so actually having it here is a bit weird. I mean, as long as they get cleaned up, it's fine, I guess, but it's dangerous. Very dangerous. However, we do have our protection here, we do have protection here. resource, create render target view with a resource. You can make that a direct 12 pointer. Because it makes sense for the render target to own the resources. So let's actually move that like so. And then copy this. Render API will need, not render API, render target, you will need this. Double reference. Yeah. Oh, it's getting a long line. I don't. Oof, Jesus, big. And this needs to be get raw. This will still work. Okay, that's fine. Render API. This index, scary. Very scary. So create render target. This should always take a resource basically. That's my next goal, I think. What's the difference between a normal pointer and a unique pointer? Well, it's not a dumb question, it's something a lot of people struggle with. So basically what a normal pointer is actually I do have a normal pointer somewhere, if I can remember, it's a render frame. So I got a normal pointer right here, right? In my eyes, this means that you don't own the data. Other will call it like a weak pointer or something. But basically it means that if you have a normal pointer, either you don't own the data or you need to do the cleanup, the management of the data yourself, which is for modern C++ not done anymore. We create unique pointers which express ownership, and it will also makes it so you can't forget to release your data in the end. So basically if you make a unique pointer, let's go to like let's just go to application. Okay, so example. Basically what you do is at the beginning of a program you're gonna make something called like player, right? And you're gonna make a pointer out of it, and that's player, and then you create new player. This is a normal pointer. Now you need to remember that on the end of your program you need to clean up that memory, because basically what this new does is it asks the operating system like, hey, give me some memory, I'm gonna put something here, and that's it. And then you get a block of memory back from your operating system, but at the end you need to tell the operating system, hey, I'm done using this, you can use it again, you can do whatever you want with it again. And normally if you have a normal pointer you need to do it yourself. So in shutdown I would have to write delete player, something like that, right? Now this is pseudocode, doesn't work because I don't have a player class, right? Don't worry about it. Now in modern C++ we don't like seeing this new and delete keyword, but if you use them, you should use them in pairs. And I think I actually have an example where I use them, but it's for arrays, which is kind of a similar thing. I think it's also in render frame, right? Yeah, I have this new keyword here, and then when I delete my class I also have the delete keyword, so these should also always go in pairs. Now what unique pointers does is it wraps that management so you don't have to think about it anymore. Whenever the object is released from memory, it will just destroy itself, it will release the memory back to the operating system, and you can't make any mistakes. So if you go to the unique pointer implementation, you're gonna see again what it actually is doing is calling new somewhere. Wait, hold on, where's my new here? Do it. Oh, this is DirectX 12 one. Never mind, wrong one. Don't look at this. This one. This will have a new keyword. And then at the end, it will have delete keyword. So what this unique pointer does is just basically wraps all of that management into one object so I don't have to think about it. And the other thing is, because it's a unique pointer, it says only one thing can have access to this memory. So there's also ownership that you express with it. You also have shared pointers and weak pointers and more complicated stuff, but it's, I mean, if you're learning C++, it's just a lookup like unique pointers, shared pointers. There's a lot of information from the standard library as well. And they can explain it like a lot better than I can. Okay. Hope that was clear enough. So where was I? Okay, so we got this random target heap. This is all done. This one is still scary. So we have this relativity index. I don't love this. I don't like this. Basically what this does is it's an index saying like, hey, use buffer at location 0 and use buffer at location 1. And I want to get rid of this full line. Basically we should do it wherever we create the render targets, which is not even in here, I think. But that would mean we need to have this RTV index done. Ah, this is annoying. Oh, did I shoot myself in the foot at the moment? Can I do device.getSwapChain? Do I make the swap chain on the device? I don't remember. Device. If so, I'm gonna just ignore the issue for now. It's on the factory. Shoot. Does the device know the swap chain? Device. Can we do this device? What do you have? Do you have a swap chain? Copy, create command list, create command list, create a evict, get descriptor, I need to get swap. Nope, no get swap chain. Unfortunate. Okay. So I can't ignore it. Great. No issue. Because basically I do this, right? But this I should do with something here. Actually, having the swap chain makes sense here though. Because I'm making a render frame for a swap chain. Oh boy. I do know a way around it, but I don't like it. I have the render API, so I can do get swap chain here. Okay, let's do it correctly. So we need resource, which is gonna be a struct, I think. Is it? Probably. Maybe. Oof. Do I have the... Yeah, okay, fine. Let's make a resource. Oh, okay. Do we need to make it a class? I don't know. Let's check out what the resource actually has. Oh boy. Okay, let's... So you, what do you have on you? Yada yada yada. Let's just look this up. Resource, it's an interface. What does it have? Does it have functions? It has get description, get hey properties map, read, unmap, writes to sub resource. Okay, so it has a couple functions, so it might make sense to make it a struct. Let's go. Okay, so for the final time today, we are gonna add files. We're gonna create a new file, card resource .h. Yes. And then in DirectX 12, we're also going to create a resource .h. And I think that's all we need for now. We don't need a CPP file at the moment, so that's fine. So in the inside render API, we're going to do this. And then we're going to make a resource somewhere here. Let's do it here. Oh, this is gonna be DirectX 12 resource. Whoops. So let's open this again. No, that's Win32. DirectX this. Where did I did the resource? At the bottom here. X12. Whew, okay. Almost made a big mistake there. Okay, and then okay, I fixed that. And then in here we're also gonna do resource. .h done, and if we build now, we will get errors because I'm not done yet, but we'll also get our resource file, hopefully. Resource file, there we go. Okay, so again, pragma once. That's include, that's not pragma once. Pragma once, and then we make our namespace. I don't know why it did render API. Then we're gonna make a struct, no, class resource, and it's gonna be public, and then it's gonna be resource, which is default. It's gonna be a destructor, which is virtual, and then again, as always, it's gonna be delete copy and delete move for now. We can always in the future add move constructors or copy constructors. Okay, that's it. And then inside this one, we're again gonna do pragma once. Then we're gonna also include resource. And then again, namespace, HP render. Like so, and then we're gonna make a class DirectX 12 resource, which is final, and it's gonna inherit from public HP render resource. And then again, we're gonna have a public because we need to. Default constructor and default destructor, which should not be marked as virtual as anymore. And actually, did I mark this one as virtual? I did. It should not about. I mean, it's fine. That makes sense. And then again, delete copy and delete move. What? I don't even have that one. There we go. Put a breakpoint for no reason. And then we're gonna have private. And it's gonna have an HP DirectX render. DirectX 12 unique pointer this time. Of an ID 3D12 resource. Resource. Done. Bosh. Great. Got a DirectX 12 resource. So inside our render frame. Oh no, let's do a render API first. Create a render target is gonna now take an HP resource. Add forward declare. Did it do it? It didn't do it correctly. Let's actually sort these. Yeah, there we go. Oh, I did this. Oh, Nobody said anything about that. There we go, that's way better. And I know how to sort. That's better. So, copy this. Render API will also need to do the same thing now. And I don't need to do this anymore. Oh, wait, did I make it just a pointer? I don't think it just needs to be a pointer. It needs to be a unique pointer to that resource, doesn't it? No, actually that can be just... Oh, now we need to clean up some stuff. Okay. So, first of all, we need to include resource, which we didn't do yet. Great, so include. And that's not how you do that. Include resource. Yo, first time here? Welcome to the stream. We're making a game engine. And at the moment I'm failing to do, well, basically anything. This resource, is that gonna be a unique pointer? Probably. Because our render target will now, instead of having a unique pointer to the resource itself, it's gonna have a normal unique pointer to an HB resource. And that's forward declared. Of course it's forward declared. Whoops. Oh, this again. Oh boy. Okay. Namespace. That will work. Then put that in there. That's fine. Wow, come on. Put that ogc-mear. Yes, that's fine. Get resource. We'll see if that's okay in the future. So that, and then instead of this, we take that. So boom, like that. And then I don't think we actually need DirectX 12 import. No, we still need DirectX 12 import. We don't need unique pointer anymore. That's great. Okay, and then we don't need this anymore, but we'll fix that in a second because this is still wrong. Okay, and then we still need to fix this. Whoops. First time here as well. Wow, 2 new first time viewers. Well, we're making a game engine. Currently, I'm fixing things with render target resources so that by the end of this, we can create everything in a render frame. Which we're getting close to, getting very close to. Okay, so create render target with the resource. No, it should be with a unique pointer over resource, and then we can move it. So let's make sure that we can move it here as well. And then we copy this, because this needs to be in the API. Boom. And the render API underlying also one frame. What the hell, OBS? Reconnection successful. You have... Okay. Whew. Jesus. Okay. We good? We done? I think the internet went out for like a second or something. That was weird. Didn't even count to my dropped frames. Anyway, as I was saying, what I'm doing for a living, I do basically this for a living. I'm a game engine developer. Although I'm more focused on actually building like the data side of the engine rather than the graphics side. So this, all I'm doing right now, all of this graphics programming, new to me as well, and I'm shit at it. Okay. I don't remember what I was doing. Okay, so we got all of this set up. Let's just actually compile and see where we go wrong, because there are bound to be errors now. Yeah, loads of errors. Okay, great. That's a good place to start. Render target. So this resource, get resource. I don't know where we call this. Where do we call this? Okay, so we do that here and here. Okay, so This is already a DirectX 12 resource, so we know that. So then we know that render resource. We can do a get underlying. And let's actually do that. Let's create a... No, we don't know the type here. Okay, so... Did I only make a header file? Oh, shoot. Oh. So what if we... For now, just do this. I really don't care. We'll make it a struct. It won't have any... Just gonna be a struct. This one is gonna be empty. We don't need defines. Why is it saying resource defined? No, resource is always defined as a struct. Don't worry about anything. And then this one, resource, yeah. And then render API probably has class resource. No, it doesn't. Great. So this one has class resource, and that should be struct resource now. And that one should now be at the bottom. There we go. Also, this go away. Compile. Let's see where we go wrong now. Actually, I don't know if I fixed the issue. Oh, more errors. Yeah, nice. Okay. That should be struct resource. And then this one, I can just do m resource. Oh. Get resource will be a bit complicated now, because we need to do get. No, we need to do dot. Yeah. Get. No, need to do boop, but we need to cast it. Where did I learn all of this? Documentation. Reading documentation using my brain. And a lot of try and error. Jesus, that's a difficult one. But I did study like game development in school, so I learned like the basics, the very simple basics of graphics programming. Completely different to what I'm doing now, but the pipeline background, how it actually works, I know, but how to set it up, I don't. So get resource. We need to cast this. Which is gonna be tricky, because that to get underlying I could make, but I can't know what I will return. Yeah. So okay, let's just bite the bullet. Static. Cast this to HB render DirectX 12 resource pointer, please. This dot get dot. Okay, apparently I don't have that yet, so I alt enter this one. I'll need to include it because I'm gonna do dot resource. And also do dot get raw. That's such an uncomplicated line for a simple thing. But that one works. So yeah, compile. See if it breaks again. It will. It will definitely break. Yeah, okay, but we're further on because I saw render API now. Oh no, it's resource. There's an error. What's an error? Copy constructor was implicitly defined as deleted. Assignment operator was implicitly defined as deleted. Okay, you are going to copy copy this, and then we are going to go to a file we haven't gone to in a long time, so I don't know if it's still where it actually is located. CMake. Compiler options. It's a compiler option, and then we're gonna do 2 of these. You and you. Implicitly deleted copy constructor. Move constructor. Okay, so those are 2 errors we're gonna ignore, so we need to rebuild now. Rebuild solution. Those errors will disappear, hopefully. Because implicitly having a deleted to copy and move constructor, I don't see as an issue. Okay, so we got others. That's it. Oh, that's not that bad actually. Okay, so render API. Create render target. We can't move the resource here anymore. I don't know why. Because, oh, I'm still passing a DirectX 12 unique pointer. No, that's gonna be a normal unique pointer. Of a resource. And then it's not gonna be resource to get raw, but oh no. What do I do here? Device to create render target view? Oh boy. We're gonna have to do that same thing again, so let's just copy it and where is it? No, it wasn't here. Yeah. You copy you. I will make a note that I need to change this. ID3D D3D12 resource pointer resource equals raw resource source. To do find better way. Okay. So now we have a unique pointer to that. Boop, boop. Okay, so we need to do that. Struct resource. Boom. Function does not take 0 elements. Yeah, that's what I thought we still needed to fix. Bro, you're leaking the source code. Yeah, that's kind of the point. I'm making the source code. Okay, so now we need to get our buffer and wrap it into a resource. And it needs to be a unique pointer. Okay. So what we need to do now is render frame. We need to get our swap chain. Okay, so render API to get swap chain. We'll make that function. Okay, this, I don't know what the swap chain is. You get swap chain m.swap chain. We'll get raw. Actually, I don't need to do that. I think that works. Oh, no, apparently not. Fine. Get swap chain function done. Yada yada yada. Render target heap. Was here, right? No. Oh, it's in render API. I'm calling it up here then. Wait, what? No, it's a render frame. Okay, so the 3D12 swap chain. No, apparently not. So direct XGI swap chain. I think it's swap chain 4. Reference swap chain. Swap chain. Damn typing. Swap chain. I'm close to showing how far we got, by the way. Oh no, render API. Render API, I can do that. Get swap chain. There we go. Do that. And then in the swap chain, we're gonna get the buffer. So how do we get the buffer from the swap chain again? I don't remember. I need the resource. So we are gonna make a unique pointer to ID3 resource. So we're gonna say HP unique pointer to a resource, DirectX12 resource. Resource equals, no, we don't need to create new. Let's just do that. That works. And then we're gonna do an ID3D12 resource pointer, and that's resource dot and resource dot get raw. Still good. That should all work. And then we will pass this in here, by the way. We'll need to move it. Like so. And now we still need to fill it in, and we do that by the swap chain. Dot what? Not swap chain dot get buffer back buffer. And it's gonna be buffer index, which is I, and then IID PV arguments of research pointer. Address of research pointer. Why is this? Okay, and then actually I don't need to do get raw here. I can just do this. Render unique pointer of the ID free resource. There we go. Wait, isn't this correct? Reference. I need to make it a reference. Whew. Okay, compile. This should work. Should. Capital should. Okay, it's compiling. Okay, we got through all of that. It's doing the application. Okay, we still got something not correct, apparently. Deleting pointer to increment type. No, the structure called. Where is it incomplete? Render target heap is not incomplete. It's here. HP unique pointer of render target heap. And then in here, we should have render target heap. It's not a... Did I implement defaults? Nope. Is this one implemented? Oh, it's defaults. Does this work? No, okay, so that wasn't the issue. This is always the annoying one, this one. So we class that. We have a default constructor, which is fine. Uh-huh. I had an issue like this before, but I can't remember how I fixed it. It should not know the type. And render target heap is all fine. Delete, copy, delete, move, create render target. We know all of these things. We have pointer to device, but that's implemented in the thingamajig. Yeah. Not sure. Not really sure. It's in create helpers. Probably. It's building engine core, which is base application, which is mainly empty, and then creation helper. Class render API, create render API. So let's go to the implementation here. That's all that needs to be there. Right, and then render API doesn't need to know anything. Render target resource. I'm confused, as always. Really confused this time though, because I don't see how it could be wrong. I'm implementing it here. I don't use it here, right? No. Get swap chain. That's implemented. That's imported. Yeah. Included. So why is it complaining about? Oh, did I include unique pointer? It's there. What do you mean? It's there. I don't get it. Why is render command list here? Just because we return it, I guess. Oh. It's because we create it? No, it should also not be in there. Oh, that's a normal one. Why do we have the normal one? Huh. Okay, let's just... I don't want to figure it out. So let's do... and the target heap. Compile. It should compile now. If it doesn't, then something else is horribly wrong. It does. Run. Okay, we forgot something. Huh. Oops. Wait, no. Resource to get raw. Uh-huh. Mm-hmm. Yeah, this is wrong, because raw resource will probably be... I have a pointer to nothing. Why does it have a pointer to nothing? What's on the stack? Create render target? Resource, unique pointer, no pointer filled in. Yes. And then get buffer, so resource pointer. Okay, let's plop a breakpoint in here. Let's see what's going on. Okay, so we got an empty pointer. We fill it in. Couldn't read its memory, so it should be a null pointer. Yes. Ow. But then after that, if you go one step further, this resource should now be just null. No, wait, this one should be filled in. Oh, but it's a reference. Okay. What if we do it a little bit different here? So we get this, right? So we create this, and we create that. Delete. And then this is gonna be create unique pointer of a DirectX 12 resource with the raw resource. Moved. It might not work still. Yeah. So this one, we're gonna create a DirectX 12 resource with honestly this reference raw resource. Oh, then we're gonna have to make a fucking a CPP file for this. Now it should be a class. Oh no. Oh, and this should be public, by the way. Oh, it is always public. Never mind. Also, this is not needed because it's fucking structs. Oh boy. Yes. I just want to make this compile, run again, and then I'm gonna end the stream. I'm gonna let you know right now. Okay, so raw resource. Yeah, we go here, resource. That's all fine. Okay, so we're gonna have to make a CPP file for this, which I don't want to do. So let's just, there we go. m.resource std move raw resource. There we go. Compile. Oops. Will that work? Seems to. Debug. So I know I still have my breakpoint, probably. I don't. But I do have a working application. I'll call that a win. I didn't put on my lights. Ah, it's too late now. Oh man, okay, so all of you who missed the beginning of the stream, I had a little bit of a rushed start. We later found out in the stream I took the wrong mic, so that took me like half an hour or longer to figure out. I apparently didn't put on those lights. I still had to set things up. I didn't get my tablet installed. It's great. Anyway, got all of this figured out. Boom, done. Okay, so let's go back to our scratch pad, because I think we can... Technically, no, we're not done with it, but it's for next week. Finish. Finish it. Yeah. We're almost done with it, I think. Technically we're done with it, but it's not that clean, is it? But who cares? Who cares? It's fine, it works. It works. And now we can just supply a resource. And technically we could also make sure that we can make one if we don't have one yet. So we could also make or create render target without a resource, and then we'll make one. But that's not fine, it's okay. That's fine. Okay, so done. Let's actually commit all of these changes and say that, and then version files as well, and then create it. Render frame. Done. Commit. And I'll actually push domain as well. Push anyway. Great. And that's where I'll leave it today. So for next time, what do we need to do? I want to be done with this render API so bad. This was basically the hardest one still to figure out, I think. So we got a little bit more work here. I want to look into synchronization. Because I'm pretty sure I should have one event per back buffer basically, and I have 2. And then I probably also will have 1 command list per, and so I'll need 2 as well. But that's all for next time. Next time I want to finish up all of this and then maybe start working on this. Because if we get there, then we're getting so close to being done with the render API. So close. And then we can finally render 2 triangles. And then we can look into doing 3D. But I'm not sure if I want to do 3D before I work on the actual game engine structure. Because what we're doing now is all the render API. But we need a way to store all the data for a render API, and that will be ECS based. But that's for the future. That is definitely for the future. For now, I will sign off, I think. Yeah, I think we've accomplished quite a lot. We've accomplished something I was dreading to do, which was making the render frame, which will eventually in the future allow us to add things like render passes or multiple render targets. Which is nice. It will be more complex. It will make the render frame very complex, but at the moment it's just 2 functions, so I don't see it as an issue. At the moment though, my time is running out. So I'll try and find the end stream button. I do think it was a very productive stream. Very productive indeed. We did have our technical issues at the beginning, and by next time I hope they will probably be all sorted, but I'll have a phobia of looking at my microphone before starting the stream and getting it and making sure it's the correct one. Either way, I think we're in a pretty good spot, so I'll leave it here, and I'll see you next week. Goodbye.